All right, welcome to the second video for 6-7. What we're going to do now is, now that you guys have been able to interpret some data from data tables, we're now going to write exponential functions when we're given just a little bit of information about their graph. So remember, an exponential function looks like this. Okay, this is a positive exponential function that is going up. It's a crude drawing, but that's roughly what an exponential function looks like. So it's going to be of the form y equals a times b to the s, where a is a constant and b is our base constant. And again, b is our base. So these are two different values. When we're trying to find our exponential function, we need to know both the, again, constant that we're multiplying our base by and our base that we're taking the exponent of. So there's two parts. Again, y equals a b to the x. So that's our general form. Now, when we know 2 points on the graph, we can actually use those 2 points to create a system of equations that we can then solve. So here are the steps. The first thing we do is we're gonna substitute both coordinates, both points, to get 2 different equations. So when we look at our points, we've got 1 is our x value and 6 is our y value, and then 3 is our x value and 54 is our y value. So when we go ahead and we substitute those into our equations, we get the following. So we plug in 1, 6. We get 6 equals a times b to the first. Again, all we've done is used our standard form for an exponential equation and plugged in our points. We're going to make a second equation using the second point. So now we get 54 equals a b to the third power. Okay, so now what we've done is we've created 2 equations because we have 2 unknowns. We're solving for a and b, so we need two equations to find that. So now we're just going to do a little bit of substitution here to go ahead and find this. Now remember, b to the first power is just b. So really we have 6 equals a times b. What we can do is we can just solve for a by dividing by b. So we get a equals 6 over b. So this is what we get from equation 1 right here. We get a equals 6 over b. Now what we can do is just take this and substitute it into our second equation. So now we get 54 equals, we know that a is just 6 over b, so we get 6 over b. Again, we're just replacing a with 6 over b, and then times b to the third power. Now, we've got one equation with one variable that we can solve. Now, this b and this cancel, so we end up getting 54 equals 6b squared. And now it's simple. We just divide by 6, so we get 9 equals b squared. And when we go ahead and we take the square root of both sides, we're just going to get 3. Now we're taking the positive square root because remember, our base, this is a positive number right here. That's why we're taking the positive. So we get 3 for b. Now, to go ahead and find a, we take this, we plug it back in here. So we get a equals, we get 6 over 3. We're just, again, substituting 3 for b, and we get that equals 2. So a equals 2. What this means is that we have now found our values for our function. So we get our function, we go ahead and we plug them back in to our standard form. So y equals a, which is 2, times, let's put our base in parentheses here, 3 to the x power. So again, 2 is our constant, 3 is our base, and x is our exponent. So that's how we get an equation given 2 points. We just create a system right here, and we go ahead and by plugging these values in, we get our system. We just go through and using substitution, solve for our 2 unknowns, plug them back in. Okay, so now what I want you to do, there's a problem I want you to work on. You can always come back and look at this work, extra help. I want you to do this example right here. So we've got a function, an exponential function, so use the standard form y equals ab to the x, and the 2 points that this graph passes through is 110 and 340. So go ahead and write your equation in the text box now. For our second example of this video, we're going to now do a similar type of problem, but now we're going to pull our data from a data table. So here we've got a table, and this shows the number of trampolines that a store has sold during its different years of existence. So y is the number of trampolines sold, and x is the number of years that it's been open. So in its first year it sold 12, second year 16, third 25, fourth 36, 550, and so forth. So you can see that this has, you can see that the different data here, it's gone up by a large amount every year that it's been in existence. Now, first thing we want to do, when we have real world data, the common difference is they're not always gonna, it's not always gonna fit a perfect model. But we're using a function to model the data, so we want it to look as close to it. So if we look at these numbers right here and we plot them, this looks like an exponential function. Again, it doesn't mean that there's an exact value, an integer value that it's multiplying by each time, but it looks like an exponential model. So we can use our generic form, our standard form, y equals ab to the x, to write an equation. So we need to pick any 2 points to write the model. Now, we can, in this case, let's choose 1 and 12, and really we can do any. Let's just do 4 and 36, because that's what the book chooses. Now, it's always nice to pick, if you have a choice and you have an x value equal to 1, it's always nice, because if you look at your generic or your standard form, ab to the x power, when you have x equals 1, that's going to get rid of your exponent. You're just going to have y equals ab. So if you have the choice from a data table, an x value of 1 is always a nice point to pick. So let's go ahead and we're going to use these 2 points. So we go through. First thing we need to do is set up both of our equations. So again, 12 equals ab to the first power. This is what we get from the point 1 comma 12. Our second equation, 36 equals ab to the fourth. Now, using our substitution, we can go ahead and we'll solve for a. So we get a equals 12 over b. Again, we just divided both sides of our first equation by b. Now, if we substitute into equation 2, so we take a equals 12 over b, and we substitute that into equation 2, we get 36 equals, we get 12 over b times b to the fourth. Now, in this right here, you're going to get that our b cancels with our fourth power. So we're left with 36 equals 3b cubed, or 12b cubed. We divide by 12, and we're going to end up with b cubed equals 3, which means b is just equal to the cube root of 3. That's how they got the answer right here. So the cube root of 3 is roughly 1.44. Now, when we take back in this one, we get a equals 12 over b. When we divide 12 divided by the cube root of 3, we get a is roughly 8.32. So we're doing the same steps as before. This time we just pulled our data from a table. So now we've got our A and B values that we've roughly rounded off to 2 decimal places. If we plug them back into our standard form of y equals ab to the x power, we get y equals 8.32 times 1.44 to the x. And that's our exponential function that models our data. So for another practice problem for you guys, I want you to look at this table right here, and I want you to go through all the same steps. So this is the data table of a store that sells basketball hoops. Shows X is the number of years they've been in existence, Y is the number of hoops they've sold per year. And I want you to write a function that models the data. So again, follow all the same steps that we just did on the last one. And I want for your what you type in your input, I want it to be the function. So make sure you have your numbers as accurate as possible, round them off to 2 decimal places if needed.